Alright, Unit 7 exam review. Draw a right triangular prism in the space below. I'm going to make it a right triangular prism in the space below. So I'm going to use right triangles for my bases. There needs to be two of them because it is a prism. Again, I'm going to try to dot the sides that you would not see. Try to bring this on the inside a little bit so you can see it. And then this one, try to bring to the outside a little bit so you can see it. There's your right triangular prism. Two bases. Draw an oblique cylinder. Again, that's a cylinder that the bases are still parallel, but they're just not right on top of each other. There's no perpendicular lines connecting the bases. So that's your oblique cylinder for number 2. Number 3, we're looking at the pentagonal pyramid. How many lateral faces? Those are just the sides. It has 5. The shape of the lateral faces are clearly triangular. More specifically, they are isosceles triangles. How many bases does it have? 1. How many edges does it have? It has 5 on the base and then 5 lateral edges for a total of 10 total edges. For number 4, which segment is the slant height? That would be EG. Slant height has to go down the center of a face and be perpendicular to the base, so EG. And the height would be EF, again from the vertex to the center of the base. So that is page 1 of your exam review. Page 2. Number 5 kind of bled through there, that's okay. Plane section parallel to the bases. Parallel to the bases, just kind of make it look just like the bases. I like to shade them in, makes it look more three-dimensional. There it is. That would be a circle. If the base is a circle, parallel to it, plane section is going to be a circle. Number 6, perpendicular to the bases that passes through the diameter. Okay, well, the diameter has to go through the center. And I'm going to kind of draw it on an angle so it gives it that three-dimensional look. These should be parallel. There, it went through the diameter. So I'm just going to cut straight down, perpendicular to the base. There's my plane section. Perpendicular to the bases that passes through the diameter of each base. The shape, that would be a rectangle. Draw a sphere with a radius of 1.7. Sphere is just a circle. Try to give it a three-dimensional look. If the radius is 1.7 centimeters, I'm just going to draw the radius and label it 1.7 centimeters. Sketch a small circle. All you got to do there is put another circle that does not include the center. There's a small circle. Number 8, name the shape of any plane section not parallel, not intersecting the base of a right cylinder. That would be an ellipse. Again, that's when real quick right cylinder. If I cut not parallel to the bases, it's going to take on kind of an oval shape, but we don't call it an oval, we call it an ellipse. Number 9, as precisely as possible, name any plane section parallel to the base of a regular triangle pyramid. Now this is a tough one because this is not, what's shown here is not a regular triangle pyramid. That's looks to be a regular, some type of quadrilateral pyramid. So a regular triangular pyramid would need a triangular base, which means it would look something, I guess, a regular triangle, and you're going to kind of lay it back a little bit. But then it's going to connect up here, so it's going to look something like this. This is a regular triangular pyramid. This is your base. So parallel to it, you're going to get the same shape as the base, which would be a regular triangle. Okay, so that's kind of confusing. You're not using this picture as far as I'm concerned, because that is not a regular triangular pyramid. For number 10, we get into the Pythagorean theorem. We want to know the length of xy. Well, I want you to focus on the triangle that's inside of the pyramid here. That is triangle AXY. That is a right triangle. AY, they tell you, is 25. AX is 24. And we want the length of XY, which I'm going to call B. Again, when you're trying to find the length of a side of a right triangle, You use the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the legs. So this would be 24 squared plus b squared equals 25 squared. I'm going to do my math now. I know that 24 squared is 496. I'm sorry, 24 squared is 576. So this is 576 plus b squared equals 625. I subtract 576 because I want to get b all alone. When I subtract 576 from each side, I get b squared equals, this would be 49. And then finally, to get b, I have to square root 49. So the length of xy, which is b, is 7, which is the square root of 49. That would be how you would do number 10. Next page, which I believe is the last page. Yes, it is. For number 11, we want the slant height now. Same thing as before. We're using the Pythagorean theorem. We're just focusing on the triangle AXY again. Only now it tells us AX is 48 and XY is 14, and we want the slant height, which is AY. So in this case, we know the two legs, so 48 squared plus 14 squared equals, I'll just call it AY squared. Using our calculator, if we do 48 squared plus 14 squared, that equals 2,500, which is AY squared. And then to get AY all alone, we square root, and the square root of 2,500 is 50. So the length of AY is 50. Now to find the area of one lateral face, now we're going to switch and we're going to look at, if I can just, you look at my pen here, we're going to look at the area of this triangle right here, ABC, okay, which I just shaded in. I'm going to look straight on now, I'm going to draw it. Here it is, A, B, C. We just found the slant height in part A, which is 50. Now even though it's the slant height for the pyramid, it is the height of this triangle. Okay, so remember, for the area of a triangle you need 1/2 times the base times the height. Well, we know that 50 is the height. The base now, from C to B or B to C, that's going to be 2 times the distance from X to Y. Okay, because we have a square pyramid here. So X to Y is 14, which means from B to C is 2 times 14, which is 28. So the area here is 1/2 times 28, which is again the length of the base, times the height, which is 50. 1/2 times 28 times 50 is 672, and that is the area of one lateral face. For number 12, does a cone have reflection symmetry? Yes. How many symmetry planes? An infinite number. Anytime you have a circular base and a right figure, you have an infinite number that go through the vertex and through the base. That's circular. For number 13, it says a right octagonal prism is shown at the right. It's not. But if it's a regular octagonal prism, yes, it does have reflection symmetry. And what I need you to focus on here is if you go down the base, and let me try to draw my best regular octagon. If you go down the base, this has 8 symmetry lines down the base. It has 1, 2, 3, 4. Those are the ones that go through 2 sides, and it has another 5, 6, 7, 8. Okay, so through the bases you have 8 symmetry planes, but since it is a prism, looking at it from a side view, for a prism, you're going to have one that cuts it perfectly in half between the bases, so you would have a total of 9 symmetry planes for a regular octagonal prism. For number 14, which 3D figure most resembles a math book? That would be a right rectangular prism. Okay, remember 3 names: right or oblique, name the base, and prism or pyramid. So there you go. And then for 15, draw the net for a regular pentagonal pyramid. A regular pentagonal pyramid tells me that the base is a regular pentagon. So there's my best effort at a regular pentagon. Here you go. We'll make it regular by marking it. Okay. Since it's a pyramid, it only has one base, so coming off each side will be a triangle that it would fold up to create a pyramid. So I'm going to have isosceles triangles, yeah, going up, and obviously these in all reality would be the same shape and same size. And again, now each of these triangles are going to have the same length sides, so you would need to mark all these. That is a regular pentagonal pyramid, excuse me. And that is the Unit 7 review.